All right, the final thing, geometry students, that we're going to learn is called conditional probability, and it involves the idea of intersection, which you guys are familiar with, and then probability just in general. So I'll just kind of talk about this right here. If you've got an event, two events basically, so it's saying the probability of one event given a second event, okay? Then the actual answer to that is going to be the probability of the intersection between those two, of the second, or the first and the second events taking place at the same time, over just the probability of the second event. So I'll show you what I mean. So right here it says find the probability of D given E. So first of all, we need, for this one, using that formula, we need the probability of the D and E, which we have over here, okay? So probability of D and E, that's what that is, this right here, okay? Over the probability of the second event, which is E. So the probability of E will be the second event. So that's what I mean by that. The probability of the intersection, so that's what that is, over the probability of the second event. So look at the second letter, and that's the probability you want to put on the bottom. So if we just do that right here, the probability of this, the D and E, is 0.15, and then the probability of E is 0.2. Okay, and so if we were to figure that out, this should actually be pretty easy, but I'm just going to make sure I have this right. So 0.15 divided by 0.2, yep, 0.75. So that would be our answer for that. That's conditional probability, but we'll look at an example of that. So now this one, find the probability of E given D. So again, you want to do the probability of D and E on the top over the probability of the second event, which is D. So this one's a little bit different, but you know, nice and easy because they already gave us the probabilities here. So 0.15 goes on the top again, over the probability of D is 0.7. So now 0.15 divided by 0.7, 0.21, we can just say 0.21 around 0.21, okay? So that's conditional probability. So we'll use this down on the chart. So given the following table of grades from Mrs. Hardcase's English classes, what's the probability that a randomly selected student got an A or a B? So look at the totals for getting an A or a B. Okay, so A, there's 20 students, and a B is 15 students. So that's 20 plus 15, that's 35. And again, you'd want to put, if it's probability, it's out of how many students. We'll look at the total down here. Okay, the total is 100 students. So that's 35 out of 100. And you could reduce it, but for now, we'll just leave it. What's the probability that an A student is male? So what's the probability that you'll have an A and be a male, basically? So look at A and male, where they intersect. So that is 12. 12 out of 100. Okay? So we keep going. What's the probability that if a student was female, so if they were female, so I think that means given that they are female, that they got a passing grade. So we'll say passing given female. Okay, because that's what it sounds like it's saying. So what's probably if a student was female, that they got a passing grade. So what's the passing grade given female? So let's look at how many females we have. That's going to go on the bottom. Okay, we could do the probability of one over the probability of the other one, but I'll show you what I mean. We can actually, there's like a shortcut. So probability that it's a passing grade. Okay, so we're going to consider passing grades for our sake, A, B, and C. Okay, we're going to consider those passing. So 20 plus 15 plus 30, that's passing. 20 plus 30, the easiest way I can think of, is 20 plus 30 is 50, and 50 plus 15 is 65. So the top number would be 65 total passing grades. And again, that's 65 out of 100. Okay. Oh, that's right. Never mind. We got to do the intersection. So what's the intersection of, so we're going to do this. Remember, it's the intersection of the two. So passing and female. So let's look at passing grades are here that are female. So we actually have to add up 8 plus 9 plus 13. So we want, remember, intersection of these two would be passing and female. So again, passing grades that are female, we're going to write down these three numbers. So that's 17 plus 13, which is 30. So 30 will be the amount of ones that are passing and female at the same time. So that will be the top number of our final answer, but I can show you that it's 30 out of 100 as a probability. And then what's the probability just female? Okay, remember, so it's the probability of the intersection of these two over the probability of the second event. So the probability of female only is, if you look on the chart, females, there's 44 females out of 100. So 44 out of 100. So now you could divide those on the calculator, but the hundreds end up canceling, and you'll just end up with 30 over 44. So what I usually do is I just look at the probability of the two together, and I just find that number on here. So like passing and female, I just find that number, which is 30. I put it on top. And then I find the number for just females, which is 44, and I put it on the bottom. And you can reduce it if you want, but that ends up being the final answer. All right, what's the probability of, so let's say that's probability of that, 30 over 44. And again, we can reduce it, but we don't have to. What's the probability of a male given that they failed? So again, we're going to say male given failed. So again, we got to figure out how many male students failed. That's the intersection of the two. So again, D or F will be fail. So, and they're going to be male. Let's look males on the chart, D or F. So males with a D or F, that's 14 plus 7. Okay, that's 21. So 21 is my top number. And then what's the probability of people that failed altogether? That's the probability of the second event, right? So if I look here, people that got a D or an F, that's 22 plus 13. Okay, that's 35. So then that is my final answer for that. 21 that were both male and failed over just failed. Okay. What's the probability of a randomly selected student just that they're male in general? There's no given or anything. So what's the probability of just male? Okay, that's what they're asking for. So we can just look at the males. How many males are there? 56. So all we have to do is say 56 over 100. That's it. That's a nice one. What's the probability of a female student given they got a B? So probability of female given they got a B. So again, top number, we're going to look for the intersection of the two. So female and B. So let's look up here. Female and a B. That's 9 people. Okay, so that's our top number. And then our bottom number is going to just be the probability of getting a B. It's the probability of the second event. So let's look at B's. 15 people got B's. So 9 is the probability of female and B, and this is the probability, or this is the number of people that just got B's in general. What's the probability, last one, of a randomly selected student passing Miss Hardcase's class? So now let's just look in general of all the passing grades. Okay, we know the bottom is going to be 100. So probability of just passing in general is getting like an A, B, or C. So we know there's 100 kids in there. So A, B, and C, we kind of already figured that one out, but we added 20, 30, that was 50, plus 15 more was 65. So that's where that probably I had to cross out. That's where that actually comes into place. 65 out of 100 is just passing in general.